Hello friends, welcome to my YouTube channel Physicscafe by Manjeet Kaur. In this video, we study about force and law of motion. In previous chapter, we have studied about motion in a straight line, in which motion, velocity, acceleration of the object changes. So, what is the reason behind them? So, in this chapter, we study about the cause of motion, that is force. In class 8th, we know the definition of force, that is, push or pull of an object is considered a force. Push and pull come from the object interacting with one another. But this definition is not enough in class 9th. So we have to add some factors in this. So we have study detail. Here are some examples of force used in everyday life. To move a tire faster, it has to be pushed continuously. The books are placed on table which is in rest to change its state. So we have to apply force. When we pick a book from the table, its state gets changed from rest to motion. When the cricketer hit the ball from the bat, here force is applied. The force of your feet pushing on pedal when you ride your bike. So these are some examples of force used in everyday life. Now we have definition of force. Force is an external agent capable of changing the state of rest or uniform motion of a particular body. That means force is an external effect that is capable of changing the state. That means if the object is placed at rest, then by applying force we can change its state from rest to motion. Similarly, if an object is in motion, by applying force we can change its state from motion to rest. So in uniform motion, velocity is constant. To stop uniform motion we need to force, that means we have to push or pull. Now force has magnitude and direction, so it is a vector quantity. The SI unit of force is Newton and its symbol is capital F. Now we have the formula of force, that means the quantity of force is the vector product of mass m and acceleration a. Mathematically, we can express as F is equals to m into a, where F is force, m is mass and a is the acceleration of the object. So its SI unit is Newton or kilogram meter per second square. We know mass is measured in kilogram and acceleration is equals to meter per second square. So the SI unit of force will become kilogram meter per second square. Now we know the acceleration is equals to time rate of change of velocity. So acceleration is equals to b upon t. So we get the equation number 2. So put acceleration's value in equation number 1, which is force. So we get F is equals to mb upon t. So that is the formula of force. Now we know some effect of force on bodies. Force is always act on bodies. That means objects. It can change the object's velocity. It can move stationary object. That means if object is at rest, by applying force we can change its state. In this diagram, the football stays at rest, but when this boy kicks it, so its state gets changed. Its state comes into motion from the rest. So by applying force we can move stationary objects. Now the second example, it can stop moving object. That means if the body is moving by applying force, we can stop its motion. In this diagram, the boy catches the ball. The ball is in motion, but when the boy catches it, its motion gets stopped. So by applying force, we can stop moving objects. Force can change the shape of the object. In this diagram, the kid make many toys with the clay, so the shape of the clay gets changed by applying force. Next is it can change the direction of moving object. In this diagram, the girl hit the ball with a bat, so the direction of the ball gets changed. The last one is it can change the speed of an object. That means by applying force, we can decrease the speed of a vehicle, and also we can stop the vehicle by applying force. Similarly, if a vehicle goes on a very slow speed, by applying force, we also increase its speed. Imbalanced force, the equal and opposite force acting on a body that will not make the body move. That means when an equal and opposite force act on a body, it doesn't move because the force cancelled, so we get balanced force which doesn't move the object. The object stays at rest, its position not changed. Next we have unbalanced force, the unequal and opposite force acting on a body that move in the direction of greater force applied. That means when an unequal force applied in opposite direction, the force we applied is not equal, so that the body gets displaced from its original position and move in the direction where greater force applied. So here we have the balanced force and unbalanced force definition. Now we have example of force. How much net force is required to accelerate a 1000 kg car at 4 meter per second square? So we have solution. Acceleration is equals to 4 meter per second square. Mass is equals to 1000 kg. We know force is equals to mass into acceleration. So put the values of acceleration and mass in this formula. We get F is equals to 1000 multiplied by 4. So we get force is equals to 4000 Newton or 4000 kilogram meter per second square. So thank you for watching my video. Like and subscribe.